Hello everyone, let's start. Thanks for coming this evening for a special seminar. Christos Kollias, most of you know him. He's been involved with SDN since the very beginning. He's a senior research scientist at Orange, and today he's going to be talking about NFV, how to bundle NFV with SDN, and an open call for researchers to work on this stuff.
All right, thank you so much, Yanni, and I'd like to thank Nick and his group also for supporting these. Thanks all of you today at such a late time of the day. So I'll be talking about bundling NFV and SDN, sort of like in the open networking framework. As you see, I used all the different passwords that I used today. I can do worse than that, but hopefully we'll reach a point where makes it interesting. And so this is like work in progress, meaning that these like some thoughts that I have, and also the group behind NFV also has. And also, and if you if you don't agree with something, feel free to speak up. And if you need to ask a question or something that it's not really clear, you can stop me. Otherwise, just defer questions to the very end. So that's in terms of context. NFV is about the abstraction of network functions from dedicated hardware, and I'll get to that later on. And the kind of definition that most of us at least agrees, the SDN is the abstraction of the control plane from the data plane. So the concept behind NFV is that if you look on the thing on your left, you see the legacy network deployment that we have today in our networks, whether it's a data center network or it's a telco network or an operator network. You have all these different hardware that is dedicated to a specific network function. You have load balancers, firewalls, and deep packet inspection devices, and so forth. And you have one physical node per row, right? So we have one particular box that does something specific, and also it requires physical installing. So you have to send someone out in the field to install that. It's very static, so which means it's very hard to move. It also makes it very inefficient in terms of if you need to handle spikes in the traffic, and also it's inefficient because most of them actually they're sized for peaks, right? And if it's like 10% utilized, obviously that device is underutilized. So as a result, this is very hard to scale up and out. So the vision behind NFV is that we should try to move everything into software. Okay, anything that exists today in terms of network elements and it runs on hardware, we should move that into software running on commoditized servers, essentially. And that gives rise to the virtual network appliance. So now, in order to achieve the same performance, obviously you have to use a high volume number of servers, right? Because it's not like only one server was going to match the performance of one particular box. And we say here standardized servers doesn't necessarily mean, and I want to clear that because there's misconception out there that we're talking about x86 type of architectures. That's not true. It can be any architecture, right? Some people obviously, they're using x86 platforms, and obviously that's what they advertise. But if you look at the white paper that we did in October 2012, we never said that it has to run on x86. Actually, as far as I'm concerned, you can run these functions on bare metal servers. They don't even have to use virtualization, right? But we think that in order to reach the economies of scale, that they have to run on VMs. So that's the vision of behind NFV. And everything that you see here, you get the contrast, the exact mirror description of the appliances. Now the software base, you can have multiple rows running on the same hardware because the hardware not right now is your server. It can be remotely operated, and that's a big plus for us as an operator. If we go into dispatch someone out in the field, we can run things remotely, easy to scale and so forth. Okay, so this is like summarized of the different types of applications that we see NFV fitting. Essentially, anything that runs again today in the network operators environment can be moved into software running on servers, from mobile networks to home environment, including your home router. Hopefully, any CDN security is very, very big. and traffic monitoring and so forth. So anything, again, that runs on dedicated hardware today, the vision behind NFV is to move into software. This is one slide because, and thanks Yanni for asking this question. So just to give you the framework, we operate under ETSI. ETSI is the European Telecommunication Standards Institute. It's based in Europe, but this is a global effort. We have 28 plus carriers signed on this effort, and we have more than 200 members. I've been lucky enough actually to be involved, in this group from the from the get-go essentially. So we operate as a standards body. The only thing is that we don't produce standards. So the goal here, the objective here for the ETSI NFV is to produce the specifications. We have a lifespan of 2 years, and actually we're going to expire now January of 2015. So we have 4 working groups that try to cover most of the areas that we think are of interest. From the infrastructure to the software architecture to the management orchestration, which is a very important area, as we'll talk later on. We have also reliability and availability, and also we have a couple of expert groups on security and performance and portability.
So the main output is just like guidelines?
Yes, the main output, right? The main output actually is guidelines, and in fact, we published the first set of documents November, October last year that covers the use cases, the architectural reference framework, terminology, and also an important aspect of it are the proof of concepts. So essentially, people are still, you can see how this can happen in absence of standards, well, I mean, it's sort of like an effort at this point, right, to see what it leads us. The idea is that once this group expires next year, maybe we'll see whether it's going to transform itself into a standards body, or or maybe we're going to split all the different pieces, and then different organizations actually can pick up the piece and move on. So again, we don't produce. Yes.
Can you describe the scope of proof of concepts? Like, are they in the lab setting? Are they pseudocode, or are they actually working in the field?
Right. So they have to be. Well, it varies. So we've seen proof of concept like in a lab environment, essentially, or it could be some pilot project out in the field. The objective of that is to sort of showcase what you can do with NFV, and also to expose any issues, so you can feed that back into the working groups. The way that POCs are structured is that you have to have one operator plus 2 vendors minimum, right? So because obviously this is to showcase how the operators can use NFV to essentially implement these in their networks.
Is there someone who says that, okay, this proof of concept meets the guidelines?
Right, so the process actually is quite loose at this point, so it's not like there's a formal body that says, yes or no. So essentially, ETSI and I think that the chair of the reliability group essentially said if it conforms to the guidelines that we have published, it's a go-ahead. So we have so far, I believe, 14 or 15 POCs. Some of them, are really important. Other ones, marginal. But yeah, there's not like any stringent process that says, you can be part of it or not. That's what you're asking. So it's pretty loose at this point. Okay. So I would be happy to answer more of these questions. I don't have much stuff, on the POCs and the ETSI structure, because this talk is about SDN and NFV in the open networking environment. But I'll be happy to, share slides later on if you have questions. Okay, so why NFV? So we think that NFV, presents a number of benefits. So I sort of like summarize this in what they call the VIVA principle: elasticity, velocity, and agility. That's the flexibility to rapidly, dynamically, essentially provide and instantiate those functions, because now these are running on VMs, so you can launch them whenever you think that there's a need for that. It's an increased speed time to market. This is very important for us as network operators if we want to launch a new service. In the past, or actually currently, it takes too long because we have to work with the hardware vendors. We think that once you move things into software, it gives you more flexibility and speed. and also operation efficiency, because now, if everything is running on VMs, that presents a more homogeneous type of environment versus in an environment we have to deal with many vendors at the same time. We think that this is going to lead also to reduced equipment costs, but you have to keep in mind here that instead of like buying hardware, dedicated hardware, I have to buy those servers, right? So we need to sort of like do the analysis here. We need to do this kind of exercise, trying to find the right business case and say, if I have one box here, it maps to that many VMs and actually do the actual cost, how much this is going to cost.
So no one's done that yet?
So no one has done that yet. I mean, as far as I haven't seen it, and it's not really a mandate. So we're not really, so that's why I focus less on the CapEx and OpEx benefits, and people will say, oh yeah, we think that's going to lead to that at some point, but I cannot tell you whether it's going to be 30% or it's going to be a mere 10% today. So, but we're hoping that people, will work on that, and maybe vendors can come up and say, this is what you guys are saving, and so forth. But that's going to be very case dependent, I think, in my mind. But it's a very important exercise to do, right? Because that's where the success of this thing is lies. But we think that in terms of certain OpEx, we're going to see some savings, whether it's the energy, how much electricity you have to pay for that, and especially in terms of skill set. Because now, when you start moving things into VMs, we think that the required skill set in terms of personnel is not going to be as demanding as today with the dedicated hardware. But again, this is something that remains to be seen.
So in your experience, do carriers have these kind of people that work with software, work with VMs, and less with hardware?
Yeah, so what we will see happening, essentially, so today things are run mostly by the network, by the NOC, which is the network operator center. So when you move to this environment where you have things running on servers, that's an IT department, that's right? So the answer to the question is yes, major vendors, major operators do have the resource to do that. But what we see actually is the convergence between the network infrastructure people and also the IT people. But again, I don't emphasize this right now because, again, this remains to be seen. I want to emphasize on the fact that since now we're moving things to the software, that opens up a number of opportunities for us. And plus, we try to avoid and stay away from that vendor lock-in that we have today when it comes to dedicated hardware. Okay, so we have, as part of these specifications that we're producing, we have a document on use cases. And I think there are like a number of use cases there, I think 7 or 8 or 10, I can't remember the exact number. But we've split up the use cases into architectural use cases. And so here I mentioned a few of interest. One is the network function virtualization infrastructure as a service, which is essentially this diagram here. It's not, and I'll come back to that later on to explain that. The virtual network function is a service. So where you actually can deploy a VNF. A VNF is a virtualized network function. So if you want to run a firewall, for instance, you can go to a provider that provides that as a service and get that from them, or it can be the virtualized CPE, something that you can also run remotely as a service. Then there's also the virtual network platform as a service. That's another use case. Essentially, in terms of scope, the VNPIS is larger than this one. It allows also for multi-tenancy at the VNF level. And one of the last use case presented here is the VNF forwarding graph. Now, this is the same as the service chaining, in case you've heard that term before. Now, I'm assuming that most of you have heard that before. Okay, so I'll come back to this example later on. I have a few slides to describe that. Okay, so the other set of use cases that document includes are service-oriented use cases. So these are like more, they're like bigger in terms of scope. Here you can see different, essentially entire architectures presented as use cases. We see the mobile core network, for instance, the base stations and CRAM, the home environment as in its totality. CDNs, it's another important use case for us, especially for us as Orange. We are submitting a POC on CDN. So the other interesting thing that, and I'll come back to the issue of a evolved packet called evolved VPC, is that only you can essentially transform dedicated hardware into those single boxes, but you can take entire architectures and move these into software. And I'll talk at the end about the EPC testbed that we're building in our lab in San Francisco. So you see, and then I'll also showcase how SDN also fits into that. Okay, so this is the reference architecture model that we came up. Again, this is work that was done last year, so you see a number of pieces here. The important thing to remember is that this is the infrastructure that it's the VNFs will be running on. So you see the virtual computing storage and network. And this is the actual hardware resources. That's the infrastructure, the network function virtualized infrastructure. On top of that, you have the VNFs running, and you see the OSS, the BSS system. That's very integral part of our open operators network. And on the side here, you see the management orchestration. So the management orchestration is responsible for the lifetime management of those VNFs. Now, those VNFs again run on VMs instances, right? So someone has to launch those VMs. If you need to move a VM, somebody has to take care of that. If you need to tear down, bring down a VM, someone has to do that. So that's part of the management orchestration. That's the most critical part in NFV. So you have the virtualized infrastructure manager here that manages the infrastructure. You have the managers here that manage the VNFs, and also this is the orchestrator. So this again is a very, very key component in NFV. In terms of examples here, I'm going to be focusing, most of my talk today is going to be focusing on the service chaining, which I think presents most of the interest when it comes to NFV and SDN. So here's an example of a service chain where everything is virtualized, so you don't have any physical boxes in your infrastructure. So it shows you have all these different VNFs running, and the different lines here represents the the traffic flow. The packets coming into the system. You have to somehow dispatch and say, okay, this packet has to go to the load balancer, and from the load balancer it has to go to the firewall, and from the firewall, to some other VNF, right? That constitutes the composition or chain of VNFs, of the virtualized network functions. So different colors here represent different, essentially, service chains, if you like. And again, this is totally a virtualized environment. Now, VNFs, they have a metadata associated with them because you may want to identify VNF, right? So that's an open research problem, actually. The second example is when you go to an environment, which is most likely that's where we'll start with, where you have a hybrid infrastructure. You have physical boxes that exist today in the network, and then also you have the virtualized part of it that it's going to augment or enhance the physical infrastructure. Now, having said that, because the question of migration will come up, right? How do we migrate? That's not going to be that hard because you can run these things in parallel. So you can have your physical infrastructure that runs as it does today, and also you can start building your virtualized infrastructure at the same time, right? So that's going to be an issue. We can do that in parallel. The only issue here is that when it comes to traffic, someone has to decide, okay, this packet needs to go to the physical infrastructure, and this packet needs to go to the visualized infrastructure. So I think that's going to be one of the components when it comes to hybrid infrastructures. And so essentially, it's this picture here, right? I apologize that these are not that visible. At least I cannot see them myself. But you have those physical boxes, and also you have those VNFs running. Another example here, which I think is of interest, which is kind of like new when you start thinking about the VNFs, is where you can have nested VNFs. You can have a VNF within another VNF. So that opens up new areas of research as well. Okay. So here I have like a couple of slides on these are like my personal thoughts. So when we move to this new paradigm of whether everything is virtualized, I like to sort of like pose and ask a few questions. So question number one is whether we need to build a data plane which is NFV aware, or if we need to make our our data plane NFV aware. And so with the physical hardware, again, connections between the boxes are static, so nothing moves, right? That's pretty much it. When you go to this NFV environment, everything is dynamic, and you can have VMs moving around, going to other racks, other data centers across your infrastructure. So it's totally different dynamic environment. So keeping that in mind, then the forwarding plane needs to handle that flow forwarding and switching. And you need to somehow keep track of how the flows in the network traverse across the different servers. And also, when it comes to bandwidth requirements, things are changing, because again, in the current paradigm, you have static connections, right? So the bandwidth on a specific connection is given, and it cannot be changed. But when you move things around, again, everything becomes more dynamic. So how do I make sure that I allocate the right capacity, for instance, to a service chain that needs a particular, has particular specific bandwidth requirements? And this has to be done not just at the single node level, but I think most like at the network level as well. And also we think that multi-tenancy will have to play a big role when it comes to the data plane. So the next question obviously is, okay, do we need an NFV aware control plane, right? Having said that about the data plane, so when it comes to the control plane, now servers can host multiple VNFs, right? They don't not only one visualizing function. We have the network service composition. This is the service chain I talked about. You have a number of firewalls, load balancers, interconnected. Do I need a control plane essentially to again keep track of these type of connections of creating those service chains? And also the control plane needs to maintain some traffic steering. What about quality of service and other policy rules that you may have? And also, as I said before, we're going to see, at least for some time, a mixed environment where you have virtualized and non-virtualized elements in your network. And the question I'll also ask you at the end is that, do we actually need a controller for NFV? And as perhaps as you have guessed, the third pillar here is whether we should make our applications NFV aware. And what does it mean, right? So first of all, we have to see what is the impact. It's going to be the impact of current applications that are running today on a network, and adapt these existing applications to this new environment, or perhaps design new applications that take into account the NFV environment. Also, this application, at least in my mind, has to be very optimized oriented, because now you have pooled resources, which is kind of different what you have in the past. In the past, you had dedicated resources to all these different functions, but now you have pooled resources, so you have to make sure that you use those resources effectively and efficiently. And the other thing I have here is that what's the role of the node-bound interface between the VNFs and the application. So today you don't have applications that at least maybe you have a few applications. We look at CDN, but most applications don't directly interact with the physical boxes today, right? They run on top of your system. But as we open up those VNFs, maybe you can have applications that directly communicate or interface, if you like, with the virtualized network functions. We also think that once you're going into this thing, that opens up some monetization opportunities for us, particularly for service providers. Again, these are questions I'm just throwing out to see what people think and whether it doesn't mean that Etsy actually were doing that today. This is my only thoughts. Okay, so when we published the white paper back in October of 2012, were actually quite visionary to include this Venn diagram from the very beginning. So we had the open innovation as one circle here. We have SDN, because SDN we think is an integral part of this effort. And also the third cycle here was the NFV. As you see, all these cycles intersect. Okay, they don't overlap exactly, 100%, but they intersect. So obviously, we like to operate right there. But for now, we think that there is definitely a synergy between SDN and NFV. These are independent technologies, they're independent architectures, if you like. They don't depend on each other, but they can benefit if they work together. It's my also personal conviction, and actually that's what people think also within the group. So that's the intersect there. And again, keep in mind that the common denominator here is software. So when you look at SDN, you have software, and everything in NFV is actually software. So that simplifies things a lot when it comes to essentially leveraging SDN in NFV. So let's see what kind of role SDN then can play in NFV. So in my mind, I think it can play a big role in the orchestration of the infrastructure, whether it's physical or virtual, when it comes to the provisioning and configuring those VNFs. Again, someone has to do that, right? It's not like I don't plug a box into the network, and even if I do, that you have configuration running on that one, but here it's more like an ad hoc type of environment. Allocate and manage resources, for instance, bandwidth. You have to, again, maybe have to move VMs across servers or even across data centers. Automation, programmability, security and policy control, very, very important when it comes to NFV. And maybe, SDN can provide that unified control and management plane. Another area that I think that SDN can play a key role is the service chaining, which is exactly the forwarding graph that I talked about before. Again, you need someone to essentially direct those flows to VNFs. And though most of you are familiar, obviously, we work with OpenFlow. If you look at the OpenFlow switches, then OpenFlow can be one tool essentially to do this type of traffic steering across the NFV network. The other important thing is being able to characterize traffic flows. So if I know that the flow has been originated from a mobile user, that might be important in terms of handling that flow in the network. I think that would be key for us. And when you look at the end-to-end type of scenarios. So NFV, again, has this dynamic environment with SDN provides that nice logical map of the network. So I think that can become handy. You'll need to set up virtual networks eventually in an NFV network. So we think, again, SDN can play a role here. And this is going to be ad hoc and on-demand, essentially, virtual networks. We may have to extend the management orchestration to include network management. Again, there's a question mark here. Now, when it comes to actually, bundling those, SDN and NFV together, I don't think it's going to be that easy, essentially, because you have to deal with, environments which is like virtualized and non-virtualized, right? And so if it's a virtualized environment, it's easier to integrate SDN, but if it's something which is not virtualized and we have legacy equipment, that's going to be a bit of a challenge when it comes to at least SDN. And also, what happens if you have to run NFV across SDN boundaries, right? You have an SDN domain and another SDN domain, but you essentially want to run NFV across these. That might be another area of research. But in essence, we think that SDN still can enable and simplify and automate implementations of VNFs. So, and apologies if you guys don't agree with me on this thing here, but that's like simplified version of SDN. You have your hardware resource here at the bottom. You have interfacing protocols running between the SDN layer, and on top you have application services, functions, utilities, anything that runs essentially on top of your SDN control layer. And you have the different APIs. This is very, very important, obviously, to provide the glue between different layers. NFV is the reference model I presented before. So if you look at an SDN-based NFV, maybe you have something like that, which is not much different than the NFV picture. The only thing here is that it have the SDN controller perhaps part of the management orchestration. So we think that, at least in my view, something like that can be integrated here. And you still need those APIs and interfaces to run in your infrastructure. Okay. Again, we can discuss that, but that I don't think anybody disagrees with that. I think this is something that we have essentially adopted in NFV, but we don't have yet the details of how this is going to be implemented. Open networking and NFV, as we're looking at different things and different open efforts. As you know, open is being used and abused today in many contexts. So when we talk about open networking, okay, we need to answer, what should be open? So should be just open source, which is the software. What about the design, the hardware? As you know, there are efforts going on within the OCP project, the Open Compute project, open standard. That sounds like an oxymoron because the standard, is a standard, right? There's no open and closed standards. But what I mean here is maybe something can start as an open effort in terms of standardizing, and then it can lead to a standard that can be adopted by one of these standardization bodies. Open interface, APIs, open SDKs. So in my mind, if you ask me, okay, what should be open, how would you define an open networking system? I would probably say that it has to include at least two of these. Two of these, should make an open. You can say only one should make it open, but if we want to be a little bit, stringent about it or a little bit more fair about it, I would probably say at least you need at least two for something to qualify as an open networking system. It is important to have an open ecosystem behind it that people can coalesce and say, contribute into this. It's very important that anything which is open is not controlled by a single vendor. So that's very, very important. Decoupling of software and hardware, essentially that's what an open networking system is. The benefits, and this is stuff that I guess you guys know about. The important thing here is the modularization, because now I can choose those different pieces. Once you disaggregate the hardware from the software, I can customize my system, and I can get the best of breed for different components, whether it's the software or whether it's the hardware. You have different things going on today. You have the bare metal switches that are being offered in the market. Then you have big switch networks providing the software. You have Cumulus providing software and so forth. So we see this kind of movement happening today in networking, and I think this is good. But let's see what that's going to be. Reduce costs, obviously, because now you can customize things. That's rare. And the other thing for us is the flexibility to be able to upgrade when we need, because things are running in software, right? So if I don't like something or something happens to that company, I can. It's not going to be as seamless as it sounds, but if I want to, go to another vendor, it gives me more flexibility. Issues again is how do you integrate all these different pieces, and who's going to do this integration? And back to your question, it's not going to be us as operators. So I don't think we have the skill set to take, a bare metal switch and the software and say, oh, I'm going to put those things together and run these. We perhaps have to rely on third parties to do this, integration. There are also other issues involved when it comes to at least the carrier environment, whether it's the high availability and SLAs and all of that nice stuff that comes when you're with a carrier, including regulation, security, and so forth. I'm not going to go through the list here. The one thing I'd like to point out here, when I was working on these slides, it just occurred to me that the virtual switches actually will have to play a big role when it comes to this type of environment. And the reason I mention that is because when I talk about service chaining, and I think we have only about 10 minutes left, you'll see why I think that's going to be very, very important. Okay, so this is the same architecture again. You can see how the different open efforts map into this picture here. You can see the the honor system, the DPDK from Intel, the OCP down here, and OpenStack. I think OpenStack still can play a big role in this picture. And I think OpenStack is the next slide. And I've been thinking about OpenStack for a long time now. And so from a previous picture, OpenStack fits into two areas. One is the area where it actually is used for managing the virtualized infrastructure, which is exactly what happens today. But I think also there's a huge potential for OpenStack to play a role in managing and orchestrating the VNFs themselves, the virtual network functions themselves. And actually, there was a summit last week in Atlanta, and they started talking about NFV with the context of OpenStack. Again, it can be extremely important in setting up those multi-tenant networks for NFV, resource management and scheduler. I think that's important. And the one bullet here that I throw here is that maybe OpenStack can become the open solution for that service chaining. Because the risk here is that once you go into this service chaining, we see different efforts from vendors today, right? So company A says, oh, here's my service chaining solution, but it works only with company B, C, and D, right? But if you have a VNF from company E, how do you make sure that these can be plugged into your that service chain? So I think, in my mind at least, like open efforts can provide the solution here, right? And obviously, obviously some vendors won't like what I'm saying, but yes.
Why is it like that? I mean, if you put a network function into a VM, right? It doesn't matter what the VM is, right? So why is company A's service chaining solution not working with any VM, just B, C, D's VMs?
Well, ideally that should be the case, right? But I cannot guarantee for sure that this is going to happen, right? So let me talk about service chaining, and we can discuss that, because I have a few slides of service chaining. So we can. So I mean, ideally that would be the case, right? But you have to have the right interfaces for that. But let me talk about service chaining, and I'll come back to that. So the other thing that really comes up a lot is the network as a service. So once you move everything into software, and you can see that this can run on VMs somewhere, what people call cloud today, that opens up opportunities for service providers to offer things as a service. So that's the so network as a service comes back. We can essentially offer slices of the network to third parties. And the other thing about OpenStack, I think it has the richness of APIs, and I think that's what really makes it appealing to NFV. Okay, I think I'm going to skip this slide because we're running out of time. Let me talk a little bit about the research, and then the last topic I have is the service chain. So, because one of the reasons I want to talk to you today also is that we're coming out with a number of research topics, and these being Stanford, we hope that some of them might be of interest to you. So we have a list of research topics that we announced and on our website, and that includes everything of course that is a potential area of research. I mentioned service chaining, the orchestration, algorithms, NFV controllers, SDN controllers for NFV, traffic steering and dispatching. You have to look whether it's a pure virtualized environment or a hybrid environment. Performance studies, and that goes back to the issue that I talked in the very beginning. I'd like to see, where you can compare apples to apples, right? And what are the resource requirements when you move things into VMs? We've not done that yet. Any latency measurements, optimization techniques, system bottlenecks that people might discover. So going back to the question why we haven't done that, so what has happened today is that some operators have independently done performance studies before starting actually NFV, and they were able to see themselves. I haven't done these studies ourselves within Orange. They were able to see the benefits of moving these into virtualized environments. but have not seen a concrete thing yet, whether it's under Etsy or by a vendor that says, this is the hardware solution here, the box, and if you move things into VMs, you need that many VMs, and these are the requirements, and this is how much it's going to cost you to deploy this solution. So when I used to work for a small company around here, one of the things I used to do back then was use cases. So when we need to move to business use case, when we have to move to when trying to deploy new technology, we have to work the numbers. Okay, does it make sense to move into this technology? And usually also there's some things involved in terms of return to investment. Yes.
So why don't the people who do the 14, 15 POCs, why don't they do that? I mean,
because
wouldn't that be
yes,
the very first?
Right. So no, because first you have to prove that something works, and once you prove something works, then it's okay if it works. Okay, does it now make sense to do it?
Could be the other way around.
It could be the other way around.
Yeah, I mean, the part of does it work?
Right. But how do you know that?
The right performance. Right?
Yeah, but first of all, you have to make sure that something works, right? When something works, it's okay. Now I can move things into VMs. The question that comes up, okay, how many VMs do I need for that? Right. So, but I mean, it can be the chicken and the egg. You could have started, saying that, okay, let's do the economics. So, as I said, one operator, I think it's public, it's Telecom, they've done performance studies prior to, to embarking on NVIDIA, and they show that there are, some benefits. But for me to be convinced and say, the question is not whether we're going to be saving anything. The question is how much we're going to be saving. Right? It's going to be 30% savings. It's going to be only 10% savings, or it's going to be as dramatic as 80%.
Yeah.
So that's, and again, it's going to be very, very case specific. When you look at these different use cases, the CDN will have different savings from the EPC or something else. So, and then you have to think that these are things that we're still evolving, right? We have vendors coming up with our software solutions, so we try to plug this in and see where it leads us. Okay, that's the cost-benefit analysis I talked about. Again, this is security is very, very important. Business continuity and disaster recovery. All these different areas, consolidation of VNFs, algorithm for nested VNFs, complexity, energy efficiency, service assurance, and maybe, my vision is that might be able to come up with new VNFs, virtualized network functions that we couldn't have done before for whatever reason. That's what I hope that one day we'll be able to achieve. You can find more information on our portal, which is not a very friendly portal, unfortunately, but there's a link that goes to NFV research. Okay, so the last but one topic is service chain and service insertion. So in a service chain, in which environment you have the physical switches, and also you have the virtual switches that connect to the VMs, right? And you have these service chains represented here by traffic flows. So one flow can test the virtual firewall, the load balancer, the T-packet inspection, the PCDN, and so forth. Another one might touch only the firewall without having to go through the load balancer. But in this picture, what I show is that each of them has to touch the virtual switch, right? It can be a virtual, I mean, it doesn't have necessarily, but I don't think we'll be able to send, to be able to link those, right? You have to go through the virtual switch, right? There's no other way to provide direct connectivity. So that's why I think that the virtual switch, can play, it's a very important functional block in this architecture. And again, it's a virtual switch, so it can build any software tools on top of that to support the things like quality of service, traffic metering, service assurance, all of these nice things, and monitoring. So, and the other thing I show here is that, it's not that visible, is that all these different instances of the same virtualized network function, they have to form a virtual network. And because now different functions are sharing the same infrastructure, right? The same servers, right? And same network. But somehow you need to provide traffic isolation. And that's what I think virtual networks become very, very handy. Again, how you create that, there are like different ways to do it today. You can use virtual network overlays, entitling approaches. Maybe you can use metadata to essentially tag the applications. And also what you can add, interesting thing you can do is that the policies actually determine the chain order. So not everybody has, and this is the added flexibility of NFV. Now you have everything virtualized. You can define your own order of how these things are going to be chained, right? In the past, it was again static. One box connects to another box. Of course, you have, if you want to connect them in a different way, you have to send someone out. But now things are virtualized. You can connect them any way you want. And that opens up the what I call here programmable service chains. We can actually make this in a programmatic fashion. And then you can, being a software, you can do branching loops, whatever. Okay, so virtual suites are very, very important here. When it comes to redundancy and disaster recovery, you have to wonder, if a virtual switch goes down because it's running on a server, you have to say what is the redundancy, what is the plan in case something goes down, right? So do I need to have a stateful architecture or has it to be completely stateless? Again, this is an open question. I don't have the answer for that. How you provide all these performance guarantees and language and structure for describing those service chains. We think that's another area of research. Describing this forwarding behavior, accounting for constraints, security or bandwidth, and so forth. Okay, I'm going to skip that. What I presented here is that you have, this is the current environment. You have three, isolated networks. When you move into virtual machines, they're running somewhere on the cloud. They get the control plane, essentially controlling these VMs. Let me skip that. For network virtualization, I talked about. What I want to show you as the last thing is what we're working on in our office in San Francisco. So we're working on a VPC test. The VPC is the Vault Packet Core, constitutes the mobile packet core for the LT architecture. So this is the architecture for the EPC. So there have been some efforts around to virtualize the entire architecture. So these are like different boxes, right? You see the packet gateway, the service gateway, the MME, all these are like different boxes running in the network today. So there are efforts to actually virtualize all of these boxes. So once you visualize all these boxes, essentially you visualize the entire architecture. The interesting thing about this thing here, the way I present it, is that there are two approaches you can do that. So one approach is what they call verticalized. So you take one of these boxes, right? It could be the MME, the mobile management entity, and you can say, okay, I'm going to map that particular box into a server, and that function is going to be running on a number of VMs, right? And that's what you see here, right? That's one server, another server, and so forth, right? And it's running all these different VMs. So essentially, a physical box is mapped to a VM that actually to multiple VMs to be exact, but run on one particular server. And that's quite inefficient because it requires many processes to run these things here. And if you want to add capacity, right? You have to essentially duplicate the whole thing here. Let's say you want to add capacity because authentication, for whatever reason, you want to authenticate more users, right? You have to essentially duplicate the whole solution here. That's why we think it's inefficient. There are other approaches. Essentially, they say, okay, instead of verticalizing that, we can run things across. So this authentication functionality can run on many VMs that runs across my infrastructure, right? It's not one single VM per function. And if I need to add capacity with respect to authentication, all I need to do is launch more VMs. So that gives you more flexibility. What happens here is that sort of like it breaks down the VPC architecture in a way, right? It doesn't violate it, but it breaks down from the way it was originally designed. So I present this as an example of the benefits that one can get with virtualizing the network function. This is called node disaggregation, right? It's sort of like mapping one box into a number of VMs that run on the same server. You just run this across a number of servers. So essentially, you remove any boundaries between those functional boxes. So that's what people call the cloud EPC. And the last piece I want to present here, and we think what actually NFV and SDN meet, is that once that things are running in software, it's easy to integrate other software solutions. So one thing that we did with EMPS back there a couple of years ago was to use OpenFlow to do mobile traffic offloading, right? So you can use OpenFlow and to say, okay, I want that particular flow to be offloaded and into a Wi-Fi network. So and the access network discovery selection function is the one which is responsible for essentially identifying Wi-Fi's in the area, right? So if I have an SDN-based mobile traffic offload solution, in the past I have to go to Ericsson or Alcatel-Lucent and say, can you please integrate this software solution into your box? And since I'm Orange, they say yes, I can do that, but it will take 3 years, right, to do this, integration. But today, let's say if I have a vendor who does works on these particular solutions, I can take their solution and plug it into my software-based AMDSF, right? Assuming that, again, the interface exists. And that goes back to your question whether, so the answer is, hopefully we like this interface in the service chain to be compatible, but nobody can guarantee that, right? We don't know this is going to happen. So that's what I think it's the beauty of when it comes to NFV and SDN is because both are software, so you can easily, at least in theory, integrate solutions into each other. So I think doing that, I think this is a very exciting actually use case that demonstrates both SDN and NFV and how you can use SDN in NFV environment. Okay, I think that's all I had. Any questions? Did I answer your question or? Yeah. So yeah, so the interface, so I know for sure that here's what happens. So when you get these management orchestration solutions from vendors, these solutions, and I don't want to throw names here, they only work with particular software vendors, right? So, and we might see the same thing with service chain. There's nothing today that guarantees, I mean, hopefully, but we don't know what kind of hooks the vendors can put there, right? Because as you see, when it comes to this, what happens today is that anything who provides a hardware solution, they say, here's also our software solution, right? And they want to protect their business. So we don't know whether you might see partnerships forming, right? And so when it comes to service chaining, we don't know how this, because again, we don't know how to chain those things yet, whether it's going to be using metadata. So if this, we're going to use some sort of metadata, maybe it's not going to support the same format without metadata. If it's more an open solution, like if we use SDN to do the traffic steering, maybe it might be easier. I don't know. I don't have the answer to how this is going to play out. Any other questions? Yes.
So
that I can answer.
IETF has this group called Service Function Chaining, which is looking at the same problem as what VNFFG is. So are these two groups, is the HC group and the IETF group, are they working together? What is the relationship between the two?
So I don't know the answer to that question. I know that such a group exists. So what happens is, again, as I said, we expire in January next year. So what we said that there are like different pieces here that fit in other organizations. So they can propose solutions. I don't think we work directly with them, but it doesn't mean that, so service chaining is one use case, right? It's not that we're trying to build a solution that, we don't try to standardize that. So, and I'm thinking that IETF, they're trying to provide some sort of standardized solution around that, I guess. So we are aware of it, but we're not working directly with them.
Okay. So are you feeding requirements into them? Is there any kind of?
So the only thing that we have published so far in terms of requirement is that reference architecture. to be honest. So there are some gaps. Actually, we have something what we call gap analysis. We're trying to define the different gaps and how we fit with other organizations. And obviously, IETF and the Broadband Forum, ONF, of course, are relevant to us. But again, this is still, work in progress. So, yes. Yeah.
So one question. Do you see, while you're making this shift from hardware appliances to software, the functionality which is within appliances to be breaking down to simpler components that scale individually?
Yeah.
I'll give you an example. For you're mentioning the virtual CPE, where the modem that we have at home will be on a data center. So is this going to happen as a NAT, a DHCP, a rate limiter, an accounting all together? Or do you see having a separate NAT function, a separate DHCP function, and these things run in parallel, and you're doing heavy chaining on individual functionalities?
It could be either. I think mostly it would be, to answer this question, it won't be operator specific, because not all the operators are running the same home gateways, obviously. So some will have more flexibility than others. So I think it's more like an implementation issue. The essence is that we definitely want to simplify. So we want to make that home gateway as simple as possible, with very little software that we can control remotely, essentially, because we don't want to be in the business of changing that home gateway every so often, right, upgrading it or anything like that. But how this is going to be done, I don't think it's within our scope, right? It's more an implementation issue. Bob, you had a question? Yeah, I know. So it's a good thing I'm running out of time.
I haven't actually raised my hand.
Yeah.
So
I came only here today for you.
So I had a couple of questions. You talked about disaggregation of NFV. I've heard people to my Sierra say that for many of these things, like firewalls and load balancing, you can disaggregate to the point where they sort of don't exist as an entity at all, but are just implemented sort of as an algorithm in the SDN controller. And the functionality is actually sort of implemented at the edge of the network, say, and they suggested an open vSwitch. Do you find that? Have you looked at that, and have you found that to be the case for any of your NFV, for any of your virtual network functions?
No, we have not. But that's how we started with SDN. Right? When we're looking at SDN and we're working with OpenFlow, some of the applications actually don't need those things run separately. You can actually integrate that into the virtual switch, right? But what happens if not everybody has that virtual switch, right? I mean, how do you make sure that? And the other thing is that the VMs, when we think running things in VMs, gives you the flexibility of creating multiple instances and creating those multi-tenancy network. It makes more sense to have this individualized running on VMs rather than having anything on the virtual switch itself.
It could be a real switch, though. For example, if your customers had OpenFlow switches, you might be able to program them. Also, if like you said, the aggregation network or the central office, is the sort of data center kind of network, then you might have a whole lot of virtual switches there you could use. For example.
I mean, I think to answer your question, I think it would be more a performance issue, whether that thing can scale. But in principle, I agree with you, and that's why I said that the virtual switch is to me, it's the most important block, because you can start integrating all these things.
Okay, right? I understand what you mean now, which is when you said the virtual switch is important, that's exactly what you were talking about. Right.
Because that's how we go start with SDN, right? We're looking at SDN, we say, okay, you can use it for firewalling, for load balancers, for everything, right? So,
my other question is, I just saw Amin Badat and talked to him and Mike Rubin last night at the meetup, and they said something really interesting, which was, well, they said a lot of interesting things, but one of them was that for Google's network, they found it very useful for Google's network, they found it very useful to extend SDN to the data plane, to have programmable packet processing. And sort of, have you looked at that or found it? Do you think it's necessary or useful?
So that requires changing the chip, right?
Well, they were sort of cagey as they usually are about their implementation, but you can imagine that it could be done a lot of ways. It could be done as something in a VM using existing APIs like Click. It could be done in, like you said, an FPGA. It could also be done in something like a network processor. You might have different implementations of varying sorts of hardware, but perhaps a common API to control them all.
Yeah.
So that's sort of the thing that we're seeing.
OpenFlow 2.0 idea.
No, this is data plane processing, not control plane. You know, so an example of data plane processing that carriers do is, you know, they compress web pages or something, or you know, they compress traffic, or you know, compression, encryption. You know, lots of things. There's lots of you know, counting, measurement. I mean, DPI is certainly data plane.
Right.
So my question is, you know, have you thought about, you know, data plane APIs and trying to extend SDN so that to the data plane so that you can write things in sort of an orthogonal manner that might work on different platforms?
I've not given any thought myself. I mean, lately, I mean, when I was working at SDN like 3-4 years ago, you know, and you know, that was one of the things when it comes to SDN, because it's all about software at the end of the day and how you can make things programmable. So you can do that with kind of close to my heart. I don't see anything, you know, that's anything wrong with it. But we have not done it. Actually, for now, we don't even focus on the data plane. We're focusing on a VMS.
Yeah, the interesting
thing, very weird.
They seem to be implying that for their use cases, there were a lot of things that where you know, they didn't scale, they were pretty inefficient to implement in software on a VM,
right,
but
right.
They could be implemented efficiently in some sort of custom hardware.
Yeah, that's a good point actually, because if you ask me today whether, you know, because we said that these should be running on standardized IT and servers. If you ask me, is that going to be the case? Maybe not, because some of the functions may still require some specialized processing and an accelerated thing. And that's why I want to do the performance things first, right? Because if the performance doesn't match and say, you know what, yeah, you can do that, but maybe you're not going to get as much. Then companies like Metronome, for instance, are doing specialized, you know, hardware, server hardware for that. So yes, the answer is yes. Yeah. Okay.
Let's wrap that
Thank
now.
you, everybody.
Thanks, Christos.